In the world of Java programming, things don't always go as planned. Sometimes, unexpected events occur during program execution. These events, known as exceptions, can disrupt the normal flow of your code and lead to undesirable outcomes if not handled properly. Imagine you're building a calculator application. A user might accidentally enter 0 as the divisor, leading to a division by 0 error. Without proper exception handling, your program could crash, leaving the user frustrated. Exception handling provides a mechanism to gracefully manage these unexpected situations. It allows you to anticipate potential problems, intercept exceptions when they occur, and provide alternative paths of execution to prevent abrupt program termination. By incorporating exception handling techniques, you can create more robust and reliable Java applications that are equipped to handle a wider range of scenarios. At the heart of Java exception handling lies the try-catch block. This construct acts like a safety net, allowing you to isolate code that might throw exceptions and define how to respond if an exception occurs. The block encloses the code that has the potential to throw an exception. It's like saying, let's try running this code, but be prepared for exceptions. If an exception occurs within the block, the program flow immediately jumps to the corresponding block. The block is where you handle the exception gracefully. You can display an error message to the user, log the exception for debugging, or take alternative actions to recover from the error. This way, even if an exception occurs, your program remains in control and can continue executing without crashing. Think of a chef carefully chopping vegetables. They wear a cut-resistant glove, the try block, just in case the knife slips. If it does, the glove protects them, the catch block, preventing a serious injury and allowing them to continue cooking. Similarly, in code, let's say you're trying to open a file. If my _file.txt doesn't exist, A is thrown. Without the program would crash. However, the block intercepts this exception, prints an error message, and allows the program to continue. This simple example illustrates how try-catch blocks help you write more resilient code that gracefully handles unexpected situations. Just like the chef might use different gloves for different tasks, Java allows you to have multiple blocks to handle different types of exceptions differently. Imagine reading input from a user. They might enter text into a field expecting a number. Here we have two blocks. The first handles, if the input isn't a number, and the second, more general, catches any other type of exception that might occur. This approach allows for more specific error handling and recovery, making your program more user-friendly and robust. Section 5. The cleanup crew. Finally blocks in action. In addition to, and there's an optional block. It always executes, regardless of whether an exception occurred or not. This is useful for cleaning up resources. Think of it like washing your hands after cooking whether or not you cut yourself. You always wash up to ensure hygiene. Java scanner file reader =null, try file reader =new scanner, new file data txt, / process data, catch, file not found exception e, system.r, println, file not found. Finally, if file reader =null, file reader.close. Here, the block closes the, which is important to prevent resource leaks. Even if an exception occurs while reading the file, ensures the file is closed properly. This ensures that your program cleans up after itself, even in the face of errors. Section 6. Taking charge. Throwing exceptions explicitly. Sometimes you'll want to throw an exception yourself based on certain conditions in your code. This is where the keyword comes in. Imagine writing a function to calculate the area of a rectangle. You might want to throw an exception if the user provides negative width or height values. Java public static int calculate area, int width, int height. If width 0 height 0, throw new illegal argument exception, width and height cannot be negative. Return width * height. Here, if or is negative, we in with a descriptive message. This signals that the input is invalid and lets other parts of your code handle this specific error. Throwing exceptions explicitly gives you fine-grained control over error handling in your programs. Section 7. Custom exceptions tailoring error handling. While Java provides many built-in exception types, you can create your own custom exceptions to represent specific error conditions in your application. Suppose you're building a banking application. You could create a custom Java class. Insufficient funds exception extends exception plus. Now in your method, you can throw this specific exception, Java if, balance, amount. This makes your code more expressive and allows you to handle different error scenarios in a customized way. Section 8. Why exception handling matters. Building robust applications. Exception handling is not just an optional feature in Java. It's a fundamental aspect of building robust and reliable applications. Here's why. Preventing program crashes. By gracefully catching and handling exceptions, you prevent your programs from crashing due to unexpected events. Improved user experience. Proper exception handling allows you to provide meaningful error messages to users, guiding them toward resolving issues. Enhanced debugging. Exception handling helps you identify and isolate the root causes of errors in your code, making debugging more efficient. Resource management. The block ensures that resources like files and network connections are closed properly, preventing resource leaks. By embracing exception handling, you elevate the quality and reliability of your Java applications. Section 9. Conclusion, Mastering Exceptions, Mastering Java. Exception handling is an essential skill for any Java programmer. By understanding the concepts of and custom exceptions, you gain the power to write code that's not only functional but also resilient and reliable. As you continue your Java journey, make it a habit to incorporate exception handling best practices. Anticipate potential errors, handle them gracefully, and strive to create applications that can withstand the unexpected. Remember, mastering exceptions is a crucial step towards mastering Java programming.